Hi all, and I welcome you to my YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to go ahead with Determinants Part 2. Already in Part 1 we have seen in Determinant chapter up to area of triangle we have covered, okay, and how to expand 2 cross 2, 1 cross 1 as well as 3 cross 3, and reason behind that it has been discussed. Now coming to the next topic, it is on minors and cofactors. These are the building block, the basic block for adjoint of a matrix, then finding the inverse, and then 5 marker questions, okay, and as well as 4 marker. Let us try to understand what is a minor first. So minor is, okay, I can say minor of an element Aij. Okay, so minor is going to go with respect to an element of a determinant. Try to understand this. So we are concerned with what determinant only. In determinant, we are concerned with the element. So minor of an element of a determinant is a determinant. See, I'm trying to focus each and every word here because of MCQ also. So minor of an element Aij of a determinant is a determinant obtained by deleting ith row and jth column where the element Aij lies. So very simple. Dan saying 101 things here. Let us go there. I've taken one 4.3 exercise problem, and here we have to find minor. See carefully. Minor, for example, 2. So minor of 2. What is the location of 2 there? It is present in first row, first column. So minor of 2, it will be given by delete the row and column where 2 is present. So 2 is present in first row and first column. That's what you can see now. First row, first column. Delete that. Then you will get determinant of 3. What is determinant of 3? 3 itself. Okay. Similarly, minor of minus 4. What's the location of minus 4? It is there in first row, second column. A, 1, 2. Okay. Is delete the row and column where minus 4 is there. It is present here now. So first row and second column. So when I delete first row and second column, remaining element is what? 0. And we denote minor by capital letter M. And here we are going to give the index of the element. So here it is 1, 1. So it will be 1, 1 here. And for this, we are finding that the 0 is minor of the element, the location A12. So M12. So this index will specify about for which element we have found the minus there. So let's come back here. So it is mentioned and here denoted by capital M-I-J. Okay. So this is about the minor. And one most important thing you see here, at the beginning, what is the order of the given determinant? 2 by 2. And after finding the minor, what is the minor here? 3, this 3. And what's the order? 1 cross 1. And what is the minor of minus 4? 0. What's the order? 1 cross 1. So what I mean to say, as soon as we find the minor, the order of the determinant reduced by 1. So it was order 2. It is reduced to what? 1. So I can just have one important note that whenever we talk about minor of an element is a determinant of order n minus 1. So whatever the order is there, with respect that the order will reduce by 1 there. And from here, one most important thing is clear that if at all I want minor, the minimum order of the given determinant should be greater than or equal to 2. As you can see in this. Since it is 2 by 2, when I take the minor, it is 1. But let us suppose that I give you this determinant, whose order is what? 1. And I ask you to find the minor of this. As soon as you delete this row and column, nothing is present. There are no elements to write. That's what we are saying, that if at all we want minor of an element in the given determinant, the order should be minimum 2. Okay, and it will reduce by n minus 1. Now comes one more important concept, cofactors. Now what is this cofactors? See, coming to cofactor, just like singular only, it is just a multiple will be given for minor, which will decide the signs here, minus 1 power I plus j into mij, and it is denoted by capital letter Aij. So the cofactor, as you can see, will have minor involved, and the multiple of that will be minus 1 power I plus j. I mean to say there will be a factor, and this factor will decide whether there will be a positive multiple for minor or a negative multiple, depending on the power I plus j being even or odd. Okay, let us try to complete this problem for cofactor now. Now, if I ask cofactor of 2, what is the location? A11 is. Now coming to cofactor, going with this, index should be given. So it will be A11 is equal to minus 1 power, see this, I plus j, mij. So whatever index is there, same index. So what's the index here? 1, 1. So I'll get 1 plus 1, m 1, 1. What is 1 plus 1? 2. Minus 1 power 2 is 1. And m11, the minor, already we got 3. So I can just substitute here. 1 into 3 is 3. So this is my cofactor. So presently you can see whatever the minor we got, same cofactor we got, because with respect to sign also we got the same, because when I add 1 plus 1 I got 2, nothing but the index sum was even number, due to which we didn't found any change in the sign. Whereas you see the next one, cofactor of which one? Let us say minus 4 only. What's the location of this? It is second row, sorry, first row and second column. That this is given by come on, again let us use this formula. If I go with this formula, so it is location is A12, so capital A12 is equal to minus 1 power 1 plus 2 m12. Now coming to this, A12 is equal to 1 plus 2 is how much? 3. What is minus 1 power 3 minus 1 itself? M12, we got 0. Now you see this carefully, we got negative this time because the sum of the index is what? Odd. Okay, but minus 1 to 0 is what? 0 only. For 0, whether it's positive sign or negative sign, there is no difference. So like this we can find all the remaining. Okay, so now I just wanted you to learn this concept. Who knows, for 1 marker, if they ask minor and cofactor, you should not be in trouble. Okay, make a note of this. Okay, dear students, having understood the concept about minor and cofactors, before I forget, see, when I just solve for 2 elements, remaining 2 you are going to take as an assignment and you should be able to get it. Okay, doing assignment is the key for success after you watch the videos, okay, with understanding. Now, as we discussed in the last part 1, that there are 6 ways of expanding the determinants of 3 by 3. Now let us try to witness that, and now I'm going to make you understand that how can we get the expansion for determinant of 3 by 3 by multiplying the element with its cofactors. Okay, now first let us try to do this. Okay, then we'll go for the some important theorem, and this will be a very important understanding concept for our rest of our derivations. Okay, see carefully, I have got 3 by 3 determinant. let us first expand the way we have understood in the last class. Nothing but here we give plus sign, minus sign, and then plus sign. So let us go with the usual way, and then we'll go for the other way. Nothing but by using the concept of cofactors. Now here the usual way is what? 5 is there here. Okay. Delete the row and column where 5 is present. So what is remaining? 0, 1, 2, 3. Then minus into plus is minus 3. Then delete this row and column. What will get? 2, 1, 1, 3. Then plus 8. Delete this row and column. What will get? 2, 0, 1, 2. Now next, pause for a step. Plus minus for 2 by 2. So 5 times of multiply this. Cross multiply 0 into 3 is 0. Then minus 1 2s are 2. Then minus 3 times of again cross multiply 2 into 3 will be 6. Minus and plus is minus 1 1s are 1. Then plus 8 times of cross multiply 2 into 2 is 4. Minus 1 into 0 is 0. 4 minus 0 is 4. 6 minus 1 will be 5. 0 minus 2 will be minus 2. 5 into minus 2 is minus 10. Minus 3 into 5 is minus 15. And 8 into 4 is 32. Simplify. We are going to have, this will be minus 25 plus 32, which will give us 7. Let us take this as delta. So delta is equal to 7. So let I take this as equation number 1. What is our motive presently? Our motive is to understand the different way of expanding the determinant of order 3 by 3 by using the concept of cofactors. Okay. Now, here we have it usual method. Okay. Now, let us go one by one. So, I will just take this as A. Now, here coming to B. So, same question I will copy here. And now, as I said, our motive is with respect to cofactors. Now, let us try to multiply the element of the first row by its cofactor and just see what we are going to get. So, what is the element in first row? 5, 3, 8. So, I will write 5 and I want to multiply by cofactor of the same element. Since this element is present in A11, first row and first column, so the cofactor is what? A11. Then plus 3. Be careful, I am not writing the sign plus minus plus the way we wrote here. Let us go with the sign whatever is given. Okay. Now here what is the location of 3? It is present in first row, second column. So the cofactor will be capital A, 1, 2. By now you should understand capital letter stand for cofactors, whereas small letter stand for location of the element. Now plus 8. Where 8 is present? Location is first row, third column. A13. So the cofactors will be A13. Before I go ahead, no, understand. 5 is multiplied with its cofactor, 3 is also multiplied with its cofactor as well as 8. And you just try to see the index here. Because as I know we go, no, just by seeing the index, we should be able to comment it is present in which row or it is cofactor of which row or which column. You see, the first index, as we know, we discussed that if I take Aij, always I represents in which row it is lying and J represent in which column it is lying, as we discussed in chapter matrices. So here also this index is giving the location. See this? If you see the first index, 1 here, here also 1, here also 1. Nothing but it is from first row. Whereas you can see the index here 1, 2, 3. So as soon the index is varying, it is not in particular a row or a column element. But as soon one index is fixed for all, that is going to give you an understanding about in which row that particular element is present. And coming to this, these are the cofactor of first row. Okay. Now let us try to simplify. As we have understood that cofactor formula is Aij is equal to minus 1 power I plus j into Mij. So let us implement this. So one by one. So what we are going to have 5 times of, see, whatever index is there, same index is here, and then Mij. So with minus 1. So minus 1 power 1 plus 1 M11, then plus 3. Coming to this minus 1 power 1 plus 2 M12 plus 8 times of minus 1 power 1 plus 3 into M13. Now what is, let's try to simplify the powers. What is 1 plus 1? 2. What is 1 plus 2? 3. What is 1 plus 3? 4. So now let us simplify what we are going to get. See carefully, let's write it here. So is equal to 5 times of minus 1 whole square is 1. 1 into 5 is 5. And M11. What is this M11 stand? M stands for minor. How to get minor of an element? Delete the row and column where that particular element is present. So I want the minor of first row, first column. So come to first row, first column, 5 it is. So delete this row and column. When I delete this row and column, the remaining elements are what? 0, 1, 2, 3. 0, 1, 2, 3. Next. See here. Minus 1 power 3 is minus 1. Minus into plus 3 will be minus 3. Now, I want minor of 1, 2. So, delete the, come to first the location of the element 1, 2. Yeah, it is 3. It is present in the location first row and second column. Delete the row and column where it is present. When I delete this row, first row and second column, my elements are 2, 1, 1, 3. 2, 1, 1, 3. Now, plus, okay, 8, and here 1 plus 3 is 4. Minus 1 power 4 is 1. 1 into plus 8 will be plus 8 itself. Now I want the minor. And I want minor of 1, 3. The element present in the location of first row and third column. Come on, first row and third column is here. So delete this row and column. What you will get? 2, 0, 1, 2. I repeat, delete the first row and third column. Elements are 2, 0, 1, 2. 2, 0, 1, 2. Now, before we go ahead, now compare this with this. Have you got the same? See? Okay, it's visible. Yeah, see this? See this? And this. So, what I'm trying to convince you is, whenever we are expanding by first row by giving plus, minus, plus, actually we are using this concept that we are multiplying first row element by its cofactors. Again, I repeat, whenever we are expanding plus, minus, plus, actually we are applying the concept of multiplying the first row element with its cofactors. Okay, and since these two are same, no need to again simplify. Since this steps, all the elements are same. On simplification, I should get back 7 only. That's common sense. So no need to again solve. Now let us just comment here that here we have multiplied. We have multiplied what? First row elements with its cofactors. With its cofactors. Now let us try to take the same question and let us try to multiply one more row with its cofactors. So already first row is done here. So let us say second or third. You can go whichever you want. Let us try to go for second. Okay. An assignment for you will be along third row. You just try out and you should get 7 only back. Let us see. First are we getting for this. So now I will take as subproblem C and I will copy the question again. Okay. Delta 1 I will take this time. So 5, 3, 8, 2, 0, 1. 1, 2, 3. Now this time I am going to go for second row. I could have also went for third row, but here in second row one element is 0. So just try to use this fact and also let you understand in case some 0 element comes how to tackle. Okay. So now let us write it here. So what we wrote, now I want to multiply the second row element with its cofactor. So here let us multiply second row elements with its cofactors. With its cofactors. So now let us see what's going to happen. So coming to second row element, it is this. And what's the location of 2? It is there in second row, first column. What's the location of 0? It is there in second row, second column. So A, 2, 2. What's the location of 1? It is there in second row, third column. So A, 2, 3. Now let us try to use this fact. Okay. Now first the element here 2. Element is here 2. So delta 1 is equal to 2. And A, capital A. And what's the location of this? 2, 1. So I'm multiplying the second row element 2 with its cofactor. Then plus 0 is there here. What is the cofactor of this? Since the location is 2, 2. A 2, 2. So it will be capital A 2, 2. Then plus 1. Location of this is what? 2, 3. So multiplying by A 2, 3. Before I go ahead, no, without any hesitation, 0 into any number is 0. So why should I waste my time in simplifying that? Okay. Now let us go for the remaining. So as I'm going to apply this formula. So see carefully, 2 times of Aij minus 1 power I plus j Mij. So minus 1 power, index is 2 and 1. So 2 plus 1, then M 2 1 plus, anyway this is 0, coming to this plus 1, then minus 1 power, index is what? 2 and 3. So add this into M 2 3. And again I want to highlight, see carefully, see the index of capital A, the row index 2 2 2, nothing but it comes from second row. Okay, so as soon as one index is same for all the element, that is going to talk about which particular row or column it is fixed. Okay, now 1 plus 2, I mean to say whenever we have got one index m, it's talking about those are coming from which particular row. Okay, that's what I mean. 1 plus 2 is what? 3, and this will be 5. So now let us okay. So now let us try to simplify. So now here 2 times of minus 1 power 3 will be minus 1. So minus 1 into 2 will be minus 2. Now M21, how to get M21? It's a minor obtained by deleting the second row and first column element where it is lying. So it is there here, second row and first column. When I delete, so I'm going to have 3, 8, 2, 3. This is anyway 0, no problem. Then 2 plus 3 is 5. Minus 1 power 5 is minus 1. Minus 1 into 1 will be minus 1. Now coming to M23. So delete second row and third column. Second row, third column. I'm going to have 5, 3, 1, 2. That's right. 5, 3, 1, 2. Now let us expand. Plus minus here, plus minus here. Now minus 2 times of cross multiplication. 3 3s are 9 minus 8 into 2 will be 16. Then minus 1 times of 5 2s are 10 minus 1 into 3 will be 3. 10 minus 3 will be 7. 9 minus 16 will be minus 7. So minus to minus is plus 2 7s are 14. Minus 1 into 7 is minus 7, and we got this 7 delta 1. Now see carefully this. I got 7, and our original way of expanding whatever we had was 7 only. So both delta 1 and delta are what? Same. So it also means, what's the summary of this? Summary of this is, whenever I'm going to multiply a row element with its cofactors, we will get value of the determinant. I repeat, whenever we are going to multiply a row element with its cofactors, then we are going to get value of the determinant itself. So here we multiplied by first row, and here it was second row, and I took second row because 0 is inward. As an assignment, I want you to multiply the element by third row cofactors. You should get back 7 only. Okay. Now the question is, what will happen if I multiply a row with some other row cofactors? Some other row cofactors. Let us try to take from the same problem. Just make a note of this. Okay, dear students, I have retained the first part as it is. Now, as we discussed, let us try to multiply a row with some other row cofactors. So A, B, C is done. So I'll take D part here. Let us see what's going to happen. Then we'll discuss about the column. So now let us suppose I will take one particular row. and then I'm going to multiply that row by some other cofactors. Let's copy the question first. So I'll take this time as delta 2. So 5, 3, 8, 2, 0, 1, 1, 2, 3. So which row? Okay, let's go for the third row now. Okay. So third row, I should multiply by some other row cofactor, either first row or second row. Let us see what will happen. So let's take first row cofactor only. So let us multiply third row elements by first row cofactors. Let us see what's going to happen. See, my third row element, this is my third row. Okay, so now 1, and I want to multiply by first row cofactor, nothing but this. So for 1, I'm multiplying the cofactor of 5. What's the location of this? A11. So capital A11. Then plus 2. And I want to multiply by the cofactor of first row. So the location of this is what? A12. First row, second column. So A12. Then plus 3. And this I want to multiply with this cofactor. Location is first row, third column. A13. Now let us try to simplify. As we know, the formula for cofactor is capital Aij is equal to minus 1 power I plus j into Mij. So now 1, write as it is. Now coming to this minus 1 power, whatever index is there, add them. So index is 1 and 1, so 1 plus 1. Then capital M, whatever index is, same index here. So index is 1, 1. Then plus 2 times of minus 1, 1 plus 2 into M, 1, 2. Okay, then plus 3, minus 1 power, whatever index is there, add that. Then M, 1, 3. Now let us try to simplify this. Now, see carefully. 1 plus 1 is 2. So minus 1 power 2 is 1. 1 into 1 is 1 itself. Okay. Then here 1 plus 2 is 3 and 1 plus 3 is 4. Let us go step by step. Now see carefully. M11. How to obtain M11? I have to delete the row and column where the element is present in first row and first column. So come here. This is the element because 1, 1, no, first row and first column. When I delete, I am having 0, 1, 2, 3. 0, 1, 2, 3. Then minus 1 power 3 is minus 1. Minus 1 into 2 is minus 2. 1, 2. So delete first row, second column. When I delete first row, second column, answer is 2, 1, 1, 3. 2, 1, 1, 3. Then plus 3 times of minus 1 power 4 is 1. 1 into 3 is 3. 1, 3. I want the minor of the location 1, 3. So delete the first row and the third column. Answer is 2, 0, 1, 2. 2, 0, 1, 2. 1. 0 into 3 is 0. Minus 1, 2 is 2. Then minus 2. 2 into 3 will be 6. Then minus 1. Then plus 3 times of 2 2s are 4 minus 0. How much is 6 minus 1? 5. 0 minus 2 minus 2. 4 minus 0, 4. So 1 into minus 2 is minus 2. Minus plus is minus. 2 5s are 10. 3 4s are 12. See carefully what's happening. Minus 2 minus 10 will be minus 12. Then plus 12. Answer is 0. So delta 2 value is 0. And this is nowhere equal to the value of determinant. Nowhere equal to the value of determinant. Let us quote that. What is the summary? Summary is whenever we are going to multiply a row by its cofactor, then we will get value of the determinant. Whereas whenever we multiply a row by some other row cofactors, then the value of the evaluation will be 0, which is not the value of the determinant. I repeat, whenever we multiply a row by some other row cofactors, we will always get the value to be 0, which is not the value of determinant. Okay. Now, one question will come, sir, what about column? So, let us take column also, and then we'll start with the other concept. Make a note. So dear students, now let us take column wise, okay? See carefully. So I'll copy, I think A, B, C, D. Okay, I don't remember the number, I suppose E only. So delta is equal to, let us copy the same, 5, 3, 8, 2, 0, 1 and 1, 2, 3. I want to go ahead with, if we multiply column with its cofactor, what is the value? Okay, this is the first point. So let us multiply. Which column will take? Any other column? Suppose first, okay, second column. Let us multiply second column elements with its cofactor, with its cofactors. Let us see what's going to happen. Now, second column, I said second column. This is the second column. So now let us go ahead. What's the location of 3? It is there in first row, second column. So A1, 2. Location of 0. It is there in second row, second column. Nothing but A2, 2. And the location of this is, it is there in third row, second column. Third row, second column. Now let us try to write down that here. So 3. The cofactor of this will be this index A1, 2. Then plus 0. Cofactor of this will be this index A22, then plus 2 times of cofactor, this is 3, 2. Now observe carefully the index. If you see the first index, that is for row 1, 2, 3, it is varying. Whereas the second index 2, 2, 2. Nothing but, since second index is fixed, nothing but column is fixed. And since second index is always 2, nothing but second column. I want you to understand this just by seeing the index. Okay. Now, let us go ahead, recall what is the formula for cofactor. Aij is equal to minus 1 power I plus j into mij. So from here, 3 times of minus 1 power. So whatever index is that, add this as a sum and then minus. So here 1 plus 2. So 1 plus 2 m12 and 0 and anything is 0. That's why I said no, last class we are going to expand in that particular row or column where we have 0, so that the computation will be a bit less for us. Okay. Then plus 2, and for this it will be minus 1 power 3 plus 2 m3 2. Now how much is 1 plus 2? It is 3 and 2 plus 3 is 5. So now 3 as it is. Minus 1 power 3 is minus 1. Minus 1 into plus 3 will be minus 3. Now coming to 1, 2. Come on. First row, second column. First row, second column. If I delete the first row and second column, what we are going to left with? 2, 1, 1, 3. 2, 1, 1, 3. Is anyway 0. No problem. Now here, 2 as it is, I will write. Minus 1 power 5 is minus 1. Minus 1 into plus 2 will be minus 2. Then 3, 2. So leave the third row and second column. Third row and second column, when I leave, I am going to have 5, 8, 2, 1. 5, 8, 2, 1. Let's cross check again. Third row, second column. Yeah, 5, 8, 2, 1. Always have a double check, okay, before you expand. Now let us try to expand this. Plus, minus, plus, minus. Let's continue here. So minus 3 times of cross multiplication. 2 into 3 is 6. Minus 1 into 1 is 1. Then minus 2 times of 5 into 1 is 5. Minus 8 into 2 will be 16. So what's the symbol of this? Minus 11. And this will be plus 5. Minus 3 into 5 will be minus 15. Minus 2 minus plus. 2 into 11 will be 22. On simplification, we get, how much is minus 15 plus 22? 7. That I will now here, I'll take this as delta 3. So delta 3 is plus 7, which is same as our determinant value. So it also means that whenever I'm going to expand column wise by multiplying a column by its own cofactors, then also I will get value of determinant only. Okay, I hope this point is clear. Again I repeat, if I'm going to multiply a column by its own cofactors, again I will get value of the determinant only. Now let us try to analyze the last thing. But before that, now you can think of expanding along first column, second column as an assignment. Okay. Now see what will happen if I multiply a column by some other column cofactors. Are we going to get again 0 like row? Let us try to understand. Okay. Let us cross check. So I'll take as delta 4. Again I'll copy the determinant 5, 3, 8, 2, 0, 1. Then 5, 1, 2, 3. Okay. Things are simple. Okay. Just we have to understand and we have to analyze each and everything very detailedly. Now let us which column will multiply with which cofactors. Here we have taken second column. We'll do one thing. Let us have this itself. We'll fix with second column only, but we'll multiply either by first column or third column cofactors so that we can witness that difference. Okay. So let us multiply second column by third column cofactors. Let us go ahead. So I am multiplying second column by third column cofactors. Fine. So first let us consider second column. This is the second column. So let us write that 3 times of. I am multiplying by what? Third column cofactor. See, third column is here. So the location of this, let us first write down the location of this. What is location of 8? It is present in first row, third column. So this will be A13, first row, third column. Then this location is what? Second row, third column. So A23, and this is present in where? Third row, third column. Okay, I hope till here fine. Now let us move on. So coming to this 3. So I want to multiply by third column cofactor. So this is the index. So the cofactor will be capital A13. Then plus 1. Again cofactor is capital A23. Then plus 3 times of capital A33. Okay. So I have multiplied. Oh, wait. I want to multiply by second column. No. So cofactors I wrote correctly. But while writing, I wrote the element of third column. Let us correct it. So 3 here. Then here 0. And then here 2. I repeat, as I said, I want to multiply second column element with third column cofactors. So second column is a 302. So 302, and the cofactors are here from this column. So the index, as you can see, the same index I wrote. Okay, I hope this is clear. Now again you see, second index is fixed and it's equal to 3. Nothing but those are cofactors of third column. Similarly, let us suppose I had small letter a, small letter a, small letter a. So it means that those are the element of third column. Like this, no, we should analyze. Now let us proceed. So again, using this formula, and before that, 0 into anything means any number. Okay, 0. So 3 times of this one, minus 1 power 1 plus 3 m times of 1 3, then plus 0 here, then plus 2 times of minus 1 power 3 plus 3 into m 3 3. Now 1 plus 3 will be 4. And 3 plus 3 is 6. So 3 times of minus 1 power 4 is plus 1. 1 into 3 is 3. Now 1 3. Remove the first row and third column element. First row, third column. So when I remove first row and third column, I am going to the remaining left thing is what? 2012. 2012. Then there is no problem with this. Minus 1 power 6 is 1. 1 into plus 2 is 2. Then 1 m33. So delete the third row and third column. So delete third row and third column. What we are getting? 5302. 5320. Okay. So now let us simplify. See carefully what's the sign here? Plus minus, plus minus. Let us expand the 2 by 2 determinant. So 3 times of 2 2s are 4, then minus 1 into 0 is 0, then plus 2 times of 5 into 0 is 0, then minus 3 2s are 6, so minus 6. So this will be minus 6 and this will be 4. 3 4s are 12. Plus into minus minus, 2 6 are 12. How much is 12 minus 12? 0. And this is not the value of determinant. So one thing is very clear from here also, that whenever we are going to multiply a column by some other cofactors of the column, then again the value will be 0, which is not the value of determinant. Okay. So summary of the story. Coming to row or column, same thing. If I multiply a row by its cofactor, similarly column by its cofactor, the value will be, the obtained value will be value of the determinant. Whereas if I multiply a row by some other row cofactors, similarly column by some other column cofactors, value will be 0, and that will not be the value of determinant. One question might come, sir, what will happen if I multiply a row by cofactor of some column? You will get some other value, which is not the value of determinant. Okay, and I have just seen the value will not be always 0 if you multiply a row by some other column cofactors. Similarly, column by some other row cofactors, you can have it right. And now you can, as an assignment, you can think of taking one of the column with some other column cofactors, and you can see that the value will be 0 always. Okay, so make a note of this. Yes, dear students, having understood that concept, that is multiplying a row by its cofactors and similarly column by its cofactors will give you the value of the determinant, whereas if you multiply a row by some other cofactors, similarly for the column, we get the value to be 0, which is not the value of determinant. I have taken this MCQ question from exercise 4.3. Pause the video and think about the solution, and not only the solution, for each option what could be the value and the correct answer. Okay, pause the video and think. Now let us start. They are saying if delta is equal to this, and you can see the elements are given with respect to location, and capital Aij is the cofactor of small aij. This stands for the element, and this is small aij stands for the element, and this stands for the cofactors. Then the value of delta. Delta is the value of this determinant. If you see the first option, see carefully, coming to small letter a. Here if you see, first index is same. So here, first row element, correct? First row element is multiplied with which cofactor is checked. See the cofactors, which index is same. Can you see which index is same? Yeah, first index is same. First index stands for row. So here 3 is there for capital A. So it is cofactors of third row and elements are from first row. So here, since I can just write, since element of which row? First row is multiplied by what? Multiplied by cofactors of which row? Third row. You can see no, first index is 3 everywhere, so third row. Hence value is 0, and you know that is not the value of the determinant, so option A out. Come to option B. See the index, which index is same. Coming to element, 1 here, again 1 here, 1 here. So elements are from first row. See the cofactors. Cofactors, if you see this index 1, then again 1, again 1. So second index is same, nothing but it's a column. So the first row element is multiplied by first cofactors, first column cofactors. I repeat, first row elements are multiplied by the cofactor of first column, and that will be some number which is not the value of determinant. Okay, let us write that. as first row elements are multiplied by cofactors of first column. Elements. Cofactor of first column elements. Okay. Now let us try to move on to this option. So this is also out. This is not going to give value of determinant. Now you see this. Carefully observe. See the index for small letter which talks about the location of element. If you see, yeah, 2, 2, 2. So this is talking about second row element. It is correct now. See the capital letter A. Which index is same? First index is same. Correct. So second row element is multiplied by first row cofactor. So the value will be 0. This is also not the correct answer. So option D will be correct. But let us understand how it is. See here, 1. Which index is same? 1, 1, 1. The second index is same. Nothing but it is first column element. Okay, because it's 1. Then here also you see 1, 1, 1. So it is first column cofactor. So first column elements are being multiplied by first column cofactors. This will give you value of the determinant which is taken as delta. So option D will be correct. Okay. So I hope this is clear. See how easily we can understand each option. If we analyze like this, how detailedly we can understand the concept.